This is a limiting reagent practice question that we're going to have similar to in our test on Tuesday. A welder has two tanks for his oxy-acetylene torch. The acetylene tank is red and contains 50 pounds of acetylene. The green tank contains 75 pounds of pure oxygen. The gases are used according to the following complete combustion equation. Which tank runs out first? And how much is left in grams? So here's the balanced equation. Here, this is the acetylene. It's a carbon compound with a triple bond between the carbon atoms, so it has a lot of energy in that bond, which is released and produces a lot of heat. It has to burn with 5 moles of oxygen to give you 4 moles of carbon dioxide and 2 moles of water in a complete combustion equation. You need 2 conversion factors. The first is that 1 kilogram is equal to 2.205 pounds, and 1 kilogram is also equal to 1,000 grams. So we start off converting the 2 quantities into something that we can use in our calculation. 50 pounds divided by 2.205 times 1,000 gives you 22,675 grams. We then divide by the molar mass of each one of the substances to find out how many moles of each one of the substances that we have. 870 moles of acetylene, 1,062 moles of oxygen. Now what we do is we pick one of those 2 quantities. I started by picking that one, and I did a stoichiometric calculation. 870 moles of acetylene will react with 5 moles of oxygen for every 2 moles of acetylene. So that means we need 2,177 moles of oxygen. So in conclusion, 2,177 moles of oxygen is needed to consume 870 moles of acetylene, but only 1,062 moles is contained in the green tank. We did that here when we found out how many moles of oxygen that 75 pounds was. So the green oxygen tank will run out before the red acetylene tank does. Suppose we had started the calculation using the other quantity. Suppose we had started using oxygen. So we start with 1,062 moles of oxygen. This time our stoichiometric factors are flipped over because we're trying to find the quantity of acetylene that's needed to combine with that many moles of oxygen. So 2 moles of acetylene combines with 5 moles of oxygen. That means we need 425 moles of acetylene, which means we have an excess of acetylene. So either way, you come to the same conclusion that the limiting reagent is oxygen in this particular problem. Then to find out how much acetylene is left, we take the original quantity of acetylene, 870, and subtract the amount that's been used, so we get 445 moles of acetylene. We then convert it to grams of acetylene by multiplying by the molar mass. Here's the carbon times 2, use the oxygen times 2. We get a molar mass of 26 grams per mole for the acetylene. We have 445 moles of acetylene. That equals 11,604 grams of acetylene. We then convert it to kilograms, and we limit ourselves to 3 significant figures in the answer because we had only 3 significant figures in the original problem. So 11.6 kilograms of acetylene is left in the red tank. And just a reminder for those of you who want to compress all the basic formulas that you need to do conversions in typical stoichiometry calculations. When you go, first of all, most problems that involve stoichiometry, you're going to moles. You always go to moles, and you use the stoichiometry. If you're going from one side of the equation to the other, you might have, say, a 3:2 ratio. If you're going the other way, that ratio will be turned into 2/3. It'll be the reciprocal of the original ratio. If you want to go from moles of a substance to the number of molecules, you multiply by Avogadro's number, which is 6.02 times 10 to the 23. If you have the number of molecules and you want to go to the moles, you divide by Avogadro's number. If you have the number of moles of a substance and you want to find out how many grams it is, you divide by, you multiply by molar mass, sorry. And if you have grams of substance and you want to go to how many moles, you divide by the molar mass. So if you keep that straight in your mind, it'll serve you very well for solving all of these problems. Rather than memorizing each and every type of problem, memorize this little chart, and it'll guide you in solving every type of possible problem that can be thrown at you in limiting reagent type problems. Also remember that you can solve your problem in more than one way. You can just pick one of the reactants and follow through on the calculation, find out how much you need of the other reactant. That allows you to make a decision as to which one of the 2 reactants is going to run out first. And then, once you find out what the limiting reactant is, you start your calculation from the limiting reactant, because that's the reactant that's going to stop the reaction. Any questions?